Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In the second lecture of 7th week, today we are going to discuss some numerical problems for practice by using false position method and bisection methods. So in this lecture we are going to discuss some problems related to solution of non-linear algebraic equations by using these two numerical approaches like false position method and bisection methods. We have already discussed these two methods, but today we are going to discuss some problems for practice by using these two methods to find solutions, roots of non-linear algebraic equations. So first of all, let's move an example to find the roots of this non-linear equation. F of x is equal to x cube minus 0.165 x square plus 3.993 multiplied 10 raised to power minus 4 is equal to 0. To find the roots of this equation by using false position method and carry out the first three iterations. So dear students, as I have already told you that in the false position method, first of all choose any two initial approximation at which the function have opposite sign. The function change the sign. So let's suppose the lower limit of the interval, the lower root of the interval is xl is equal to 0 and xu is equal to 0.11. So now check if the function change the sign between this xl and xu, then the roots will be lies between xl and xu. So putting the value of this first initial approximation xl, which is 0 in the given equation, so as 0 power 3 minus 0.165 into 0 square plus 3.993 multiplied 10 raised to power minus 4, and after calculations we obtain these two terms are 0, we obtain 3.993 multiplied 10 raised to power minus 4. Now to check the sign of the function at this upper limit of the interval, function at xu, the xu value is 0.11. so putting this value in this given equation, 0.11 whole cube minus 0.165 multiplied 0.11 square plus 3.993 multiplied 10 raised to power minus 4, and after using a simple calculator we can calculate this expression which is equal to minus 2.662 multiplied 10 raised to power minus 4. So dear students, note that at xl, at this first approximation the function have opposite positive sign, and at the second approximation xu the function have negative sign. So the function have opposite sign at these two initial roots, and you see here the product of the values of the function is less than 0 because one value is positive and the other value is negative. So the product of the values at these two roots will be less than 0, mean the function have negative opposite sign. The function have opposite sign at these two roots xl and xu. Now using the formula of false position method, and note here that there exists at least one root between this xl and lu, which is 0 and 0.11. so the roots for this equation lies between this range 0 and 0.11. now using the false position method, xr is equal to xu f of xl minus xl f of xu divided by f of xl minus f of xu. So putting r is equal to 1, suppose now we have to find the root x1 in the first iteration. So putting the value of xu 0.11 multiplied the function value at xl is 3.993 multiplied 10 raised to power minus 4, and the value of xl is 0 multiplied the function value at xu minus 2.662 multiplied 10 raised to power minus 4 divided by, this is the function value at xl, 3.993 multiplied 10 raised to the power minus 4 minus the function value at xu minus 2.662 multiplied 10 raised to the power minus 4, and simplify this expression. After simplification we obtain the root 0.0661, and this root lies between 0 and 0.11. You see here we locate the root that the root lies between 0 and 0.11. So this root is in the range of between 0 and 0.11. So now to find the other approximate root, because we are going to working up to 3 iterations. So now we required more 2 iterations, iteration number 2 and iteration number 3, to find the best approximation root, the best approximate root of the given equation. So dear students, now to find the other root x2, but first of all putting this x1 in the given equation to check the sign of the function. When we put this x1 value in the given equation, we obtain 0.0660 whole cube minus 0.165 multiplied 0.0660 whole square plus 3.993 multiplied 10 raised to the power minus 4, and after simplification we obtain minus 3.1944 multiplied 10 raised to the power minus 5. So the function has negative sign at this x1. Now to find the root x2, first of all check the function sign at which two roots the function has opposite sign. So for the next root, check the sign of the function on previous root. In the previous before x1 we have two roots, xl and xu, and xl and xu the function have opposite sign at xl and have negative sign at xu. So now for the next root x2, we locate that the next root x2 is lies between this x1 and this xu. This is the xu value 0.11. So note that the function have a negative sign at x1 and the function have positive sign at xu. So the next root x2 is between x1 and xu. Now which one be the lower limit between x1 and xu? So the dear students, you see here the function product of the function value is less than 0 at these two root xl and x1. It's mean that the function have opposite sign at xl and x1. This is the value of the function at xl, which is positive, and this is the value of the function at x1, which is negative. So the function have opposite sign on these two roots xl and x1. So hence it means that the root is bracketed between xl and x1, that is between 0 and 0.0660. So the lower and the upper limit of the new bracket are xl is 0 and x1 now is equal to xu, which is equal to 0.0660 respectively. So for the next iteration, again using the formula x2 is equal to xu f of xl minus xl f of xu divided by f of xl minus f of xu. This is the value of xu, and this is the value of the function at xl, minus this is the value of xl which is 0, multiplied the function value at xu divided by the function value at xl and the function value at xu, and after simplification we obtain the next root as 0.0611. Now for the third iteration, to find x3, now again locate the roots that x3 will be between which two roots. Suppose you see here the find the, you see here this is the value of x2, so putting this value of x2 in the given equation, we obtain f of 0.0611 is equal to 0.0611 whole cube minus 0.165 multiplied 0.0611 whole square plus 3.993 multiplied 10 raised to power minus 4. So you see here the sign have opposite, the sign have positive, the sign of the function is positive at this x2, and the sign of the function at x1 is negative. So you see here, dear students, that now x3 lies between x1 and x2, but which one be the lower limit and which one be the upper limit? In the x2 and x1, you see here this is the value of x2 and this is the value of x1. Since the value of xu is 0.0660 and the value of xl is 0.0611. So now x2 will be the lower limit and x1 will be the upper limit. In this fall position method, it is necessary to locate the root and then identify the lower limit and upper limit. So in these two roots, 0.0611 is the xl and 0.0660 is the xu, because this value is greater than this value. So first of all, check the sign of the function for the next root. To find the next root x3, check the sign of the function at x2 and check the sign of the function at the previous value. Before x2 we have x1, we have xu, and we have xl. So before x3 we have the roots x2, x1, xu, and xl, and before x2 we have the roots x1, xu, and xl. So for the x3, check the sign of the function at x2 and one other root x1, xu, and xl, and you see here the sign of the function at x2 is positive and the sign of the function at x1 is negative. So the next root x3 lies between x1 and x2, but which one will be the lower and upper at x1 and x2? Check the magnitude of x1 and x2. If x1 is less than x2, then x1 will be the lower, and if x2 is less than x1, then x2 will be the lower. But you see here x1 is greater than x2, so x1 is the upper limit and x2 is the lower limit. Now using this simple formula, putting the value of x1, putting the value of xu and xl, and you have already calculated the function at f of xu and at x1 and xl. Putting the value of xu and xl in this formula, and you have already calculated the function at xl and at xu. So putting these values, we obtain now the third iteration. Xu value is 0.0660 multiplied the function value at xl is 1. And xl is now x2. The function value at x2 is 1.132 multiplied 10 raised to power minus 5, and the xl value is 0.0611 multiplied the function value at xu. This is the xu minus 3.1944 multiplied 10 raised to power minus 5 divided by the function value at xl and the function value at xu, and after simplification we obtain the third iteration root x3 is equal to 0.0624. So dear students, in false position method, first of all locate, first of all choose two values at which the sign of the function change, at which function have opposite sign. So when the function have opposite sign at the initial approximations, then find the first the other roots using the formula xr is equal to xu f of xl minus xl f of xu divided by f of xl minus f of xu. When you obtain the third root, suppose this is x1 is the third root, because we have already identified the two roots xl and xu. In that root locate the position of the roots. That roots lies between xl and xu. The initial approximation gave us the location of the root, that the root lies between these two initial approximation. So but if the function has opposite sign on xl and xu, then the roots lies between xl and xu. So find the root x1, this will be the first iteration, and when we find the second root x2 at second iteration, before second iteration, first of all check the function, check the sign of the function at x1. Suppose you have the sign of the function at x1 is negative, you see here. Now check the sign of the function at xu and xl. If the function have a positive sign at xu, then the next root between x1 and xu, and if the function have a positive sign at xl and negative sign at xu, then it's mean that the function have opposite sign at x1 and xl, then the roots lies between xl and x1, and which one will be the lower limit and which one will be the upper limit at these two roots at which the function have opposite sign. You check the magnitude of the roots. If xl is less than x1, then xl will be xl and x1 will be xu. Okay, now to start, let's start another example by using bisection method. Dear students, I have already told you in the previous lecture that bisection method gave us an approximate result for a non-linear equations, and this method we also choose their two roots, initial roots at which the function have opposite sign. So when you choose roots at which the function have opposite sign, then find the roots by adding that initial roots xu plus xl divided by 2, and similarly for the second root check the sign of the function at this x1 and xl and xu. If function have opposite sign at x1 and xu, then the next root will be between x1 and xu, so xu plus x1 divided by 2. And if the sign of the function is opposite at x1 and xl, then the roots x2 lies between xl and x1, so for the x2 add x1 xl plus x1 divided by 2, and we check for each steps the sign of the function for the next coming root. Now suppose we have an example to find an approximate root to under root 3 by using bisection method correct to two significant digits. Dear students, we can calculate easily by calculator that under root 3 is equal to 1.732050808. This is the exact result. Now to find the approximate result by using bisection method, we can write this equation taking square root on both sides. We obtain a function x square minus 3 is equal to 0. So for the bisection method, choose initial values at which the function have opposite sign. If we choose xl is equal to 1, then the function value is minus 2. Putting 1 here in this equation, we obtain minus 2. And if we choose xu is equal to 2, then 2 to the 4 minus 3 is equal to 1. So at these two roots the function have opposite sign. So by using bisection method, the roots lies between 1 and 2, and so the root x1 is adding these two roots, xl plus xu divided by 2, we obtain 1 plus 2 divided by 2, 1.5. And you see here the exact result, it was 1.7. Now we need other roots to find best approximate result close to this exact result. So for x2, first of all, put this x1 in the given equation to check the sign of the function. So at f of x1, f of 1.5, we get minus 0.75. Putting x is equal to 1.5 in the given equation, we obtain minus 0.75, and this is negative. So the function has negative sign at x1. Now check the function, the sign of the function at previous values. Before x1 we have xu, so the sign of the function at xu is positive. So the next root x2 is between xu and x1. So adding these two roots xu and x1 and multiplied, add these two roots and divide by 2, we obtain the next root x2, x1 plus xu divided by 2. This is the value of x1 and this is the value of xu divided by divided by 2. 1.5 plus 2 divided by 2 is equal to 1.75. And now to find the third root x3, putting this x2 in the given equation to check the sign of the function. So function at x2, function at 1.75 is equal to 0.06075. This is positive. So the function have positive sign at x2 and have negative sign at x1. So function have opposite sign at x1 and x2, so the next root x3 lies between x1 and x2. So simple adding these two roots x1 plus x2 divided by 2, we obtain x3 root. x1 is 1.5 and x2 is 1.75 divided by 2, which is equal to 1.625. And now to find the fourth root, check the sign of the function at this x3. Putting x3 value 1.625 in the given equation, we obtain minus 0.350. So function is negative at x3 and function is positive at x2, you see here. So the next root x4 is between x2 and x3. So for x4, adding these two roots and divide by 2, we obtain x4th root. x2 plus x3 divided by 2, this is the value of x2 and this is the value of x3 divided by 2. So we obtain 1.6875. This is the value of x4. Now to find the fifth root, first of all, put this x4 into the given equation to check the sign of the function. So function at x4, function at 1.6875 is equal to minus 0.152. So dear students, in the given equation, this is the given equation, x square minus 3. So at each step, putting the previous roots for the next root in the given equation to check the sign of the function. So for x4, for x5, put this x4 in the given equation, we obtain minus 0.125 and this is negative less than 0. So at x4 the function is negative, at x3 the function is negative, and at x2 the function is positive. It's mean that the function have opposite sign at x2 and x4. So for x5 it is clear that x5 is lies between x2 and x4 because the function have opposite sign at x2 and x4. So dear students, it is a very important point to note that for x5, check the sign of the function at x4 and at other previous value. Before x4 you have x3, x2, x1, xu and xl. Before x4 you have already 5 roots in which 3 are x1, x2, x3 and 2 are the initial approximations which we have choose at the start of the problem. So for x5, check the sign of the function at this x4 and check the sign of the function on previous roots. So if the function at any two roots x4 if the function have opposite sign at x4 and any other previous roots, then the next root x5 lies between x4 and that root at which the function have opposite sign at x4 and other root in the previous roots. So now you see here the function have opposite sign at x4 and x2. So the next root x5 is lies between x2 and x4 divided by 2. x2 plus x4 divided by 2. This is the value of x2 and this is the value of x4 divided by 2, which is equal to 1.71875. Now to find the sixth root, check the sign of the function at this x5 and at other previous root. So the sign of the function at x5 is negative, and the sign of the function at x4 is also negative, and the sign of the function at x3 is also negative, and the sign of the function at x2 is positive. So it's mean that for x6 the function have opposite sign at x2 and x5. So x6 lies between x2 and x5. This is x2 and this is x5. So for x6, adding x2 plus x5 divided by 2, this is the value of x2, 1.75 plus 1.71875 divided by 2, and x6 we obtain 1.734375. So x6 is the approximate root correct to two significant digits, because in the exact answer we obtain 1.73 and in the approximate result we obtain 1.73. So this result is correct to two significant digits to the exact result. And this is the end of this segment. Thank you. Allah Hafiz.